Let's start our section on differential equations by looking at the Laplace transform of a derivative. So we're interested in finding the Laplace transform of f derivative of t. Now the one there just signifies it's the first derivative. If it was 2 it would be the second derivative and 3 would be the third derivative. So that would equal the integral from 0 to infinity of e to the minus st times f derivative of t by dt. Now we're going to use integration by parts in order to split this up. Now this is kind of like the product rule for differentiation, except it's a product rule for integration. And if there's any one thing you want to learn on calculus, it has to be integration by parts. It's really useful. So if we look at this integral of u dv, it equals u times v minus the integral of v du. Now if we let u equal e to the minus st and dv equal the f derivative of t, then du is simply the first derivative of u with respect to t, which is minus s e to the minus st. And to get v, we integrate this and integrate that side. So we integrate that side back, you're just left with your function f of t. So we can say u times v equals e to the minus st times f of t. The integral there of v, well, v is simply our f of t, and our du is minus s e to the minus st, so the minus here and the minus here cancel to give us a plus. We take s out of this here because we're going to be integrating with respect to t, not with respect to s, so s can come out. So this integral from 0 to infinity of e to the minus st f of t by dt. So the first section here is e to the st. As t tends towards infinity, this e to the minus st tends towards 0. So the first part of that is 0. And as t tends towards 0, e to the minus st just tends towards 1. And the value here, t, will just be our 0. So we'll just simply have our minus f of 0. And that would be s times, now all we have left here is the Laplace transform of our f of t. So this is going to be equal to minus f of 0 plus s times the Laplace transform of f of t. So finally we can say the Laplace transform of our derivative f of t equals minus f of 0 plus s times the Laplace transform of our function f of t. Of course we could write this L f of t simply as f of s if we want, and we'll be doing that in the next slide. Also note that our f of 0 is equal to f of t whenever t equals 0. So let's look at the Laplace transform of the second derivative. Now we're simply iterating what we had done previously. So that's going to equal to minus the f derivative at 0 plus s times the Laplace transform of f derivative at t. So that equals minus f derivative at 0 plus, and now this is iteration here, s times minus f of 0 minus s f of s. So multiplying that out we get our minus f derivative of 0 minus s f of 0 plus s squared f of s. So finally we'll write that out with the highest order terms first. So that's Laplace transform of f, the second derivative of f, is equal to s squared f of s minus s f of 0 minus f derivative of 0. Now it doesn't matter too much if you find it difficult following where that derivation came from. All that matters is that you're able to use this and the other simple functions, Laplace transform pairs, which we'll be deriving over the next couple of slides. So again, this f derivative of 0 is just simply d by dt of our f of t whenever t equals 0. F of s is the Laplace transform of f of t, and f of 0 is equal to f of t whenever t equals 0. So if we were to extend that up to higher orders, we could say that the third derivative is going to be given by this here. We could say that the fourth derivative is going to be given by this here. And if we extend it up to the nth derivative is going to be given by this series here. So for example, if I was to look at the sixth derivative, that will be s to the 6 f of s minus s to the 5 f of 0 minus s to the 4 f derived of 0 minus s to the 3 f second derived of 0 minus s to the 2 f third derived of 0 minus s f to the 4th derived of 0 minus f fifth derivative of 0. Now, we want to simplify the notation, make it a bit easier whenever we're doing our differential equations. So what we'll do is we'll say f of 0 equals x0, f derived of 0 equals x1, the second derivative of 0 equals x2, the third derivative of 0 equals x3, so on and so forth, till the nth derivative of 0 equals x to the n. We'll also say the Laplace transform of x is given by x bar. Laplace transform of x derivative will therefore be sx bar minus x0. Laplace transform of x double derivative will be s squared x bar minus sx0 minus x1, and the third derivative, the Laplace transform of the third derivative, is equal to s cubed x bar minus s squared x0 minus sx1 minus x2. Now, there's been quite a lot of maths in this section, and it's actually easier than it looks. The application of it is quite straightforward. So over the next 3 videos we'll look at solving first order, second order and third order differential equations. Thank you for listening, and goodbye.